graphs and networks. We're looking at the different elements of a graph, I forgot the T, and how to describe graphs. One thing I want you to be really aware of in this topic, there are a lot of definitions. You'll want all the definitions on your page of notes. Lots of definitions. It's very easy, incredibly easy to get them mixed up. I get them mixed up all the time. I have to turn back to my notes. You will want these all on your page of notes. So last video we looked at the fact that there's a whole bunch of situations in everyday life where we need to analyze connections between people or objects, so computers or towns or friends on social media, and a diagram with the edges connecting these vertices that we're interested in is called a graph. So this is a very simple diagram of a social media connection graph, and these are 6 people who are connected in some way on this particular type of social media. And this says that Anna is friends with Francis, Brett, and Ethan. And obviously being friends is a two-way property, so if Anna is friends with Ethan, Ethan is also friends with Anna. So the connections are shown by the edges. You'll remember that the degree of a vertex is the number of edges that are connected to it, and we give each vertex a capital letter name, so this would obviously be vertex F, and the degree of vertex F is 3, which says, since it's an odd number, it's an odd degree. We need to look at different parts of a graph, the elements of a graph. So, okay, we've got a graph. And a graph in graph theory is a diagram consisting of a set of points, our vertices, joined by a set of lines called edges. And each edge joins 2 vertices, or, in the case of a loop, if Anna could in fact friend herself on this website, we'd get a loop like this. This is a loop. It's an edge in a graph that joins a vertex to itself. Now, it's important to note with a loop that it adds only one edge to the graph. So this added one edge, but it adds 2 to Anna's degree because there's 1, 2, 3, 4, 5 edges coming into Anna's point, her vertex. So a loop contributes 2 to the degree of its vertex. Multiple edges. Now I don't have any multiple edges here. Multiple edges is when there's 2 edges joining the same 2 vertices or more. So if, for example, Francis actually had 2 accounts and friended Dario on both of them, then we could see a multiple edge creeping in. There's 2 ways which we could say Francis and Dario are connected. And we know the degree of a vertex. The degree of any vertex, designated by a capital V, is the number of edges attached to it. So there's some definitions that we need. Now there's a couple of categories of graphs and we need to be able to identify these. A simple graph has no loops or multiple edges. So this is an example of a simple graph, no loops, no multiple edges, nice and boring. An isolated vertex is a vertex that is not connected to any other. So it has no edges attached to it. So if I add vertex F and no edges, that is an isolated vertex. A complete graph has an edge between every pair of vertices. So to make this graph complete, I would have to make sure that every possible pair of vertices had an edge between them. A subgraph is part of a larger graph with no extra bits that aren't part of the larger graph. So all of the edges and vertices in the subgraph must exist in the original graph. And if you think about it, some examples of subgraphs from this one would be A, B, F. We're just looking at how those three vertices are connected, but it's still a part of the original graph. Or we could say F, D, E, or EDF, whatever you want to call it. So that is a part of the original graph. That's a subgraph, that's a subgraph. Any set of edges and vertices that exists here, and you can see why in a larger sense we might want subgraphs if we had a massive friends network and only wanted to analyse a smaller part of it. Checking that I haven't forgotten anything. Nope, I haven't.